All right, very good evening to all of you. So this is your educator Srishti and I welcome you all on YouTube channel of Unacademy IIT-JAM Live. And in this particular session, right, we had started with IIT-JAM Chemistry PYQ series, right, and we started with Journal Organic Chemistry. We have solved some questions also from previous years from Journal Organic Chemistry. So we'll be continuing the series, okay, and we'll be taking few more questions in this session and we'll try to explain the question from concepts, okay. So what concept is actually related in that particular question, we'll be discussing that, okay. So a very good evening to all of you. Just let me know in the comment section if my voice is clear and the slides are visible, okay, so that we can start off with our session. All right, okay. So let's take questions, okay. So we have discussed this question, okay. We have already discussed this question in the previous session. Okay, this is also, these all questions are JAM previous year questions from General Organic Chemistry. Okay, let's take second question now. We have discussed this one. Let's take this question. Okay, let's take this question, and the question is the correct order of the pKa values for the conjugate acids of heterocyclic compounds given below. So you have four heterocyclic compounds, okay, and what you have to find, you have to find the correct order of pKa values for the conjugate base. Okay, so this is the question. You have to calculate the correct order of pKa for the conjugate base, for the conjugate acids. Okay, so let's see what concept is involved over here. Okay, what is the question? I'm going to read question twice before giving the correct answer, right? So whenever you have to make this habit, okay, whenever in exam also you have to select the answer, just make this habit that at least you have to read the question twice. Okay, before selecting your answer you have to read question twice. Okay, so the question says the correct order of the pKa values for the conjugate acids of heterocyclic compounds given below. So before that we should have, right, some knowledge of these terms, which terms they are using. They are using pKa, all right, they are using conjugate acid, right, then they are using heterocyclic compounds. Okay, so let's understand these three terms first. Okay, what is heterocyclic compound? From the name itself you can see it's nothing but, if I right, I break this compound in two halves. So this is hetero and this is cyclic. Cyclic means it's a closed compound. Okay, this is not a open chain compound, it's a ring. Okay, so whenever you have a closed compound, and with this closed compound you have heteroatom. Now what is this heteroatom? Generally we consider oxygen, sulfur, nitrogen, these all atoms as heteroatoms. Okay, so whenever you have this heteroatom, right, which is basically making a ring, let's suppose nitrogen, so those type of compounds are known as heterocyclic compounds. Okay, I hope this point is clear to all of you. This is heterocyclic compound. Okay, so this is what is known as heterocyclic compound. And the next thing is what is conjugate acid and what is pKa value. So let's understand that. Okay, so let's understand what is pKa. What is pKa? Okay, so let's suppose I have any acid. How I can represent acid? By this notation Ha. Okay, and what this acid is going to do? This acid is going to do H plus. Definitely, according to Bronsted acid theory, what is acid? That acid is going to lose H plus. Okay, so Ha will give H plus plus A minus. All right, so this is what is known as your acid. Okay, now let's suppose we have any equilibrium reaction. Okay, let's suppose we have any equilibrium reaction XY. This xy gives x plus plus y minus. Okay, so how I am going to write down kd? What is kd? Kd is nothing but a form of equilibrium constant, and over here it's known as dissociation constant, because we are writing this particular constant for dissociation of xy compound. Okay, so on the same note, for acid compounds I would write Ka. Okay, that is dissociation of acid. Okay, so Ka is nothing but concentration of product divided by concentration of reactant. Okay, this is how we are going to write down K equilibrium. So what is Ka? Ka is concentration of product. What is product? Concentration of H plus ion, concentration of A minus ion divided by Ha. Right, this is how I am going to write down acid, right, dissociation constant of acid. Okay, Ka is equals to H plus A minus Ha. Okay, so this is what is known as Ka. Okay, now what is pKa? So whenever you have P term with any variable, okay, Ka is nothing but a variable. This is how I can define the extent of acidity. If extent of acidity is more, this means you have more number of H plus ion. If you have more number of H plus ion, so this means the Ka value is more. So Ka value is nothing but directly proportional to acidic strength. Okay, so what is pKa? Whenever I have pKa, so I have to introduce minus log before Ka. Okay, before Ka. Let's suppose we have pH. So how I am going to write down pH in terms of logarithmic values? Minus log H plus. Okay, minus log H plus. So this is how I'm going to write down pH value. Okay, I hope this point is clear to all of you. So this is your pKa term. Now we are clear that what is pKa, what is heterocyclic compounds. Now we have to understand what are conjugate acids. Okay, what are conjugate acids? So whenever you have this term conjugate, okay, conjugate acid means it is conjugate acid of a base. Okay, conjugate acid means it is conjugate part of a base. Okay, let's suppose we have a base. How I am going to represent base in terms of your Bronsted base? Okay, BOH. Okay, this is how I am going to represent base. So BOH will give you B positive plus OH minus sign. Okay, so this B positive is conjugate acid of BOH base. Okay, this B positive is conjugate acid of BOH base. Okay, why I am representing acid word with this B positive? Because what is acid? Okay, what is acid? So basically it's a base, so this would be acid. Okay, what is acid? So acid will give H plus ion. Okay, acid will give H plus ion. So for base we have conjugate acids. Okay, so according to this concept, what we are going to do, if I'm taking heterocyclic compound, so heterocyclic compounds or nitrogen compounds are basic in nature. So what they are going to do, let's take an example, R, R, R dash, R2, R3. So this is a base. Okay, so what it's going to do, it will take this H plus ion and this will give this lone pair and it will convert this to like this. Okay, it will convert like this. So this is going to be your conjugate acid of a base. Okay, why? Because this will give you H positive ion. Okay, this will give you H positive ion. So this is a conjugate acid of a base. Okay, I hope it's clear to all of you, right? So this is what is known as conjugate acid. Okay, so this part is clear. So how I'm going to just picturize this question in my head before selecting the correct option. The correct order of pKa values, we have to write down the correct order of pKa values for conjugate acids. Okay, great. See, let's suppose we have a base. Okay, base will definitely take H positive ion. Okay, base will definitely take H positive ion and it will form conjugate acid. Okay, it will form conjugate acid. Okay, so let's suppose your base is strong, it's a good base. Okay, it's a better base or it's a good base. So what's going to happen, that its conjugate acid would be weak, definitely. Okay, why? See, whenever we are proceeding a particular reaction, so this means K equilibrium is positive. How K equilibrium is positive and what all right concepts we can conclude from positive K equilibrium? This means, okay, what is positive K equilibrium? This means that your reaction, the forward reaction is feasible or products are stable. Okay, or products are stable. So if products are stable, this means products are less reactive comparatively. Okay, this means products are less reactive comparatively. So now if your base are strong, that means it has tendency to donate its lone pair. So definitely the conjugate acid is going to be less reactive. That means it will lose it won't lose H plus ion. So this means conjugate acid would be weak conjugate acid. Okay, weak conjugate acid. Great. Okay, this point is clear. So how I'm going to relate this particular property? See how I'm going to relate this particular property. So I can write down that basicity is directly proportional or it's inversely proportional to acidity of conjugate acid. Acidity of conjugate acid. Okay, I hope it's clear. or it's inversely proportional to Ka, okay, or it's inversely proportional to Ka of conjugate acid. So definitely I know that pKa and Ka has inverse relation, so I can say it's directly proportional to pKa of conjugate acid. Okay, it's directly proportional to pKa of conjugate acid. Okay, so what can I say? That basicity is directly proportional to pKa of conjugate acid. Okay, so ultimately what I have to note down, I have to note down the pKa of conjugate acid, which is directly proportional to basicity. So ultimately I have to write, just find out the correct order of basicity. This is the clear cut picture of this particular question. Okay, so before giving your answer, you have to picturize, you have to join all points. Okay, you have to join all dots for right, just increases your chances to give a correct answer. Okay, you have to join all dots before selecting your correct answer. So what I have to find out, I have to find out the correct order of basicity. Okay, I hope it's clear to all of you. So see how I am going to just write down the correct order of basicity. So what is basicity, guys? Basicity is nothing but tendency to donate lone pair of electrons. Okay, lone pair of electrons, tendency to donate lone pair of electrons. And how I am going to test tendency to donate lone pair of electrons? Just by looking the hybridization of lone pair. Okay, how easily it can give its lone pair. This is how I am going to write down the correct order of basicity. For that, I should know that what is hybridization of atom on which lone pair is residing. Okay, then we have to see the address of your lone pair. Okay, because lone pair is going to attack H positive ion. Okay, so what we need to do first, we need to find out the parent hybridization. What is this parent hybridization? Let's suppose you have a nitrogen and you have a lone pair. Yes, you have to donate this lone pair, but before that you have to check the hybridization of parent atom also. Okay, so that you can eliminate options. Okay, so let's start with very first option. So this is your pyrrole. Okay, and what is hybridization of this nitrogen present over here? Hybridization of nitrogen is sp2 hybridized. Okay, nitrogen is sp2 hybridized because it is making double bond with this pyrrole, so it is sp2 hybridized. All right, then let's go to the next one. So in second, nitrogen is sp3 hybridized. Great, nitrogen is sp3 hybridized. In third, nitrogen is again sp3 hybridized. Okay, nitrogen is again sp3 hybridized. Over here nitrogen is sp2 hybridized. Okay, it's sp2 hybridized. Now we have two compounds with sp3 hybridized nitrogen and two compounds with sp2 hybridized nitrogen. So what we are going to do, we are going to compare percentage S character. Okay, so percentage S character, if I have to compare percentage S character, so definitely percentage S character, okay, would be more for sp2 rather than sp3. It would be more for sp2 than sp3, right? Approximately percentage S character is 33% over here, and it's over here 25%. Okay, so if percentage S character is more, this means tendency to donate lone pair of electrons decreases, right? Okay, tendency to donate lone pair of electrons decreases. Okay, if percentage S character increases, so tendency to donate lone pair of electron decreases. Okay, so over here it's sp2 sp3 sp3 sp2. So definitely in sp2 percentage S character would be more. If percentage S character is more, so ultimately the basicity will decrease. Okay, so 1 and fourth is going to have less basicity than second and third. So just by this one point, let's see if I can cancel out few options. Okay, let's see. Okay, definitely we are going to have second or third at first position. Okay, second, fourth, no, it's not going to be a correct answer. third. Okay, this might be correct answer. Let's see. Okay, third. All right, so we can cancel out one option. Then at second option we have third. Okay, so we know that second and third, right? Basically they'll take first and second position. Okay, great. Second and third. Over here it's second and third. All right, third and fourth. So definitely option D we can cancel out. Okay, now we are left with option A and option C. Okay, option A and option C. So now we have to compare in these two compounds. Okay, now we have to compare in these two compounds. Okay, let's suppose I have a 3-membered ring over here and I have a 5-membered ring. Okay, I have a 3-membered and I have a 5-membered ring. Okay, so what I'm going to say, this angle is approximately 60 degrees. Approximately rough angle, definitely it's not going to be 60 degrees because you have nitrogen, it's going to be less than that of 60 degrees. But still, let's take in the standard values of a triangle, equilateral triangle. It is 60 degrees. Okay, so similarly for 5-membered pentagon, for right 5 sides pentagon, we are going to write down 108 degrees. Okay, so approximately this angle would be 300 degrees and this angle would be 252 degrees. Okay, so what can I say, that this angle is more in if I compare if I compare outside angle. Okay, if I compare outside angle, so outside angle in 1 is more than 2. Okay, outside angle in 1 is more than 2. So if outside angle is in 1 is more than 2, so what I am going to say, that definitely percentage S character in 1 is more than percentage S character in 2, because angle is directly proportional to percentage S character. Okay, so percentage S character in 1 is more than 2. So which compound is going to donate electrons easily? Definitely it's going to be second one, right? Because percentage S character is less, so second compound is going to give electrons very easily. Okay, so what can I say, that third, second, then we have fourth. Okay, then we have first. This is going to be our correct order. Okay, third, second, then we have fourth and first. Now why we have fourth first, then first? Because this lone pair is localized lone pair. This is not perpendicular to the plane, and for p orbital, for pi orbitals, it should be perpendicular to the plane. So this lone pair is localized, it is present on nitrogen only, it's not dispersing in this ring. Okay, this is a localized lone pair and this is delocalized lone pair. Okay, delocalized lone pair, that means it is dispersing. So it's very difficult for us to donate a delocalized lone pair, but it's very easy for us to donate localized lone pair. Okay, I hope it's clear to all of you. So correct answer would be option C. Okay, correct answer would be option C. I hope this point is clear to all of you. Okay, let me know in the comment section if you have any doubt. Great, let's go to the next one now. Okay, this is your next question. The correct orientation of dipoles in pyrrole and pyridine is. Okay, this is your next question. You have to find out the correct orientation of dipoles in pyridine and pyrrole. Okay, you have 30 seconds to answer this question. Just let me know in the comment section if you have any doubts and the answer for this question. Anyone who would like to tell me answer for this question? Okay, Ramesh is going with B. Any other aspirant who would like to address this answer? Okay, let's discuss this question. So the question says the correct orientation of dipoles in pyrrole and pyridine. Before that, we should know what is a dipole. Okay, it's nothing but separation between two opposite charges. Okay, it is nothing but a separation between two opposite charges. Okay, let's suppose you have a positive charge over here and you have a negative charge over here, and this distance is represented by small d. Great. So how I'm going to write down the dipole extent or dipole moment? It is nothing but charge into distance. Okay, it is nothing but charge into distance, and the direction of dipole is from positive to negative. Okay, and the direction of dipole is from positive to negative. Okay, this is what is known as dipole, and this is going to be your pyrrole and this is going to be your pyridine. Okay, let's see that how we are going to solve this particular question. So we know that the direction of dipole is from positive to negative. That means the dipole will go in direction of your electrons. It will be parallel to the direction of your electrons. Okay, let's see how we can draw a pyrrole structure. Okay, let's see how we can draw a pyrrole structure. We know this is a pyrrole structure and we have lone pair of electrons over here, and this pyrrole, a lone pair of electron, is actually present in p orbital because it is involved in resonance. Okay, so what can I say? This can go over here. Okay, this can go over here like this. There is a resonance. So ultimately the electron is going from this position to this position. Okay, it's going from this position to this position. So what can I say? That this is the direction of your dipole. Okay, this is the direction of your dipole. I hope it's clear to all of you. Okay, so in pyrrole, downwards to upwards is the direction of dipole. Okay, let's take the case of pyridine now. Okay, let's take the case of pyridine now. So what is the difference in pyridine and pyrrole? Okay, the lone pair is also present in case of nitrogen, but the difference is this lone pair is localized lone pair. How this is localized lone pair? Let's see. Okay, let's see how it's localized lone pair. So we have pyridine. Great. How I can draw p orbital picture of your pyridine? This is how I can draw. We have 3 pi bonds, so definitely we will be having p orbitals, p orbitals, p orbitals, p orbital, p orbital, p orbital, p orbital, and p orbital. Okay, this is how I am going to write down the p orbitals like this. There is resonance over here. Okay, there is resonance over here in this p orbital. So definitely if this lone pair, right, would be involved in resonance, then this should be in p orbital, but this lone pair is actually involved, or it is present in sp2 hybridized orbital, which is in plane of the molecule. Okay, which is in plane of the molecule. Now you would think that how I know that this is not involved in resonance. See, by steric number we can calculate that thing. Nitrogen hybridization is sp2, right? Nitrogen hybridization is sp2. So what can I say? That see, sp2 means steric number is 3. Steric number 3 means number of lone pairs plus sigma bonds. Okay, so now you can see that we have one bond, two bond. All right, we have one lone pair and we have a double bond. If we have a double bond, so definitely this would have used p orbital. Now if this nitrogen would have used p orbital, so what is left now? One sp2 hybridized orbital. Okay, because we have 3 sp2 hybridized orbital. One is consumed in formation of this sigma bond, one is used in formation of this sigma bond, so third one is left, and in third orbital you have a lone pair. Okay, so this nitrogen lone pair is in sp2 and this lone pair is in p orbital. So this is going to be a localized lone pair, so it will be residing on nitrogen. So if I want to write down the orientation of dipoles, so it would be from positive to negative. Okay, so positive terminal and negative terminal. So this is going to be your correct answer. Okay, this is going to be your correct answer. I hope it's clear to all of you that option A is going to be correct answer. Okay, I hope it's clear, everybody, right? So this is all about this session. I hope you found this session useful. If you found this session useful, you can write down in the comment section. We'll be continuing this session, okay, on a daily note. Just for 4-5 days I'll be taking classes daily, so the timings would be 9 p.m. from tomorrow. If you want to continue this PYQ series of general organic chemistry, I have class tomorrow at 9 p.m. and with this you can follow me on Unacademy, where I'm taking special classes which are free of cost. You don't have to pay any penny for that. Okay, so if you want to attend those special classes, you can follow me on Unacademy, for which the link is given in the description box. Okay, and I'm taking plus courses also for IIT-JAM Chemistry aspirants. as well as for IIT Biotechnology Chemistry aspirants. Okay, so if you want to join these courses, you can take Unacademy subscription using my referral code SBATR. If you have any doubts regarding subscription or related to your JAM academics, you can message me on Unacademy platform. Just go to my profile, you will see a message box over there. Just drop in your messages over there, right? I would be happy to help you guys. Okay, so very good night to all of you and take care. I hope you found this session useful. Okay, I'll see you in the next class, that is tomorrow 9 p.m.